Okay, well, so this I've called Simple S3 Security. It's a play on the service being called Simple Storage Service. So actually, what's so simple about S3? When it was launched in 2006, it's pretty much the first service in AWS. You could store objects of varying sizes into a bucket using a key. You had simple CRUD operations using either a REST or a SOAP API. And security consisted of access control lists with read or write access. Now, all of the objects got a S3 URL, s3.amazon.aws.com/bucket name/key. And if they had read access, they were publicly accessible. Now, when we're going back to 2006, this was pretty much the first service. There was no identity and access management, so the only thing you had were account owners, and there's no support for website hosting, although obviously you could download files from those URLs. And none of all these other services we use today that talk to S3 existed. EC2 actually launched later in the same year. Why does any of that matter? Well, I think some of the history of how S3 evolved explains the way it works today, partly just to support backwards compatibility. Every object still has a URL following a well-known pattern, and this dual public-private nature has been the cause of various issues, and we've heard some other talks focusing on security mention this as well. You don't want to be in one of these articles that you get when you search for S3 data breaches, but there's a lot of them. And there's an argument that the S3 service is basically flawed by design because it's trying to serve these dual purposes, and it should be split into two separate services. One which allows data to be public and where you're not so worried about security because you're making it public, and one where everything is ensured to be internally accessible only. The trouble is that would kill backwards compatibility, and so many things are based around S3. So now we're going to talk about some of the concepts of security. And the first thing to think about is ownership. And going back to when we started with S3, there was only the account. There were no users or roles. And buckets are always owned by the creating account. And objects are always owned by the uploading account, which is not necessarily the account that owns the bucket, because you may have given someone access to upload to your bucket. Beware, though, that the owner of the bucket is paying for storing that object, so you don't want to let anyone upload large objects to your buckets. If you're using IAM users or roles, then it's the account that user or role belongs to that ends up owning either the bucket or the object. And if you've allowed the public to upload to your S3 bucket, it can end up owned by an anonymous user, which gets this long ID in the access control list. And then in terms of restrictions, we've got restrictions either from the user side or from the resource side. And the user policies are around IAM users and roles, and they're saying, what are you granted permission to do with the S service? And it's from the perspective of the account those users and roles belong to. From the resource, we're taking the perspective of either the bucket or the object and saying, what's the calling account allowed to do? Going a bit deeper here, so when we're talking IAM permissions, they're going to be attached to either a user, a role, or a group. If you are operating as that account owner, all of this is bypassed because you've got full S3 access. From the resource side, we've got access control lists on buckets and objects. Now, they always have them, but we often don't look at them a great deal because by default, they grant full control to the owner, which is the account. Now, more often, we might apply a bucket policy, and this is optional. And this is a policy that applies to the entire bucket, or a single policy for the entire bucket, but within which you can have statements for specific prefixes or even individual objects. And here's where you would typically grant cross-account access or anonymous access for website hosting, or a bunch of different things you can put in there. By default, when you create an S3 bucket or when you add an object, these are private to the account, and the account owner has full access, but other accounts don't. The public doesn't have access. Someone has to go in and do something to make it publicly accessible. And IAM users and roles have no access to S3 by default. So let's put that all together. And this diagram is straight out of the AWS S3 documentation, and there's a whole section on security that if you're interested in this topic, I would recommend you read through because it goes in far more detail than I can in this lightning talk. But we'll just go through this flow of accessing an object. So we start off as a user request, and we say, well, is the person making this request a user or a role? And if so, we look at their permissions in IAM as granted by their parent account to say, do they have access to use the S3 service at all? Do they have access to S3 get object? And if so, which resources do they have access to? Does it include this bucket? If they do, then we go on. And we start looking at things from the bucket point of view. Notice we can skip that first step if it's the account owner. Now, when we look from the bucket context, we first look at the bucket ACL and then the bucket policy and say, does that give you access or does it deny access? And if it's denied, we stop. And then finally, we look at the object itself and its access control list. And if that grants access, then we're allowed to go ahead. So we've got these different controls, but when do we use them? Now, starting with bucket ACLs, these are kind of the simplest because now AWS recommends that the only thing you use them for is for Amazon S3 log delivery. So this is where you have S3 access logs that you typically deliver to a separate bucket. As for object ACLs, well, one case you definitely want to use them is when a third party is uploading to your buckets, so from another AWS account. And typically, because in most cases, you want the owner of the bucket to be able to read the objects after they're uploaded there, you'll want the uploading account to either set the bucket owner read or bucket owner full controlled ACL to give access. It's possible you might also have a need for fine-grained access control where each individual bucket object gets a different ACL, but really, do you need this? Perhaps they should be in separate buckets or have different prefixes where you can control access using a bucket policy. Now, bucket policies are widely used for different things. So you might use it to grant public access for website hosting, but no, website hosting in S3 only has HTTPS support, so perhaps you put CloudFront in front of it. But if you're putting CloudFront in front of it for HTTPS, you might want to secure access to the bucket using an origin access identity, which is something that you put in your bucket policy. It's where you can grant access to other accounts, and then you can add various restrictions either to the entire bucket or certain prefixes. And just some examples of this is requiring access from a VPC using a VPC endpoint, requiring HTTPS because the service still supports HTTP for backwards compatibility, requiring certain types of encryption for uploading objects, plus many, many more options. As for IAM policies, well, you need to grant some or your IAM users and roles won't have access. Be careful here to just give the access that you need. For example, if you have users who are supporting a production service, perhaps they need to see which objects are in a bucket, but they may be restricted from actually opening the objects because they don't need that for their support role, and perhaps they contain PII or PHI. So be careful exactly what access you grant and don't just say, oh, well, it's read-only, it's fine. And then when you're talking about applications, tailor your roles to exactly what the individual application is doing. So if application A just talks to a specific single bucket, don't give them access to read from all of the buckets that you have in your account. So for example, if your WAF EC2 instances don't need to be able to read financial data, don't give them access to it. Now, because of all of these data breaches, AWS has introduced various new features to S3 as layers on top of them to prevent some of these problems. And one of them is block public access. And you can really think of this like a firewall for your buckets. Essentially, it's these 4 checkboxes or a single checkbox to turn them all on that prevent certain types of public access. If all you're doing is using the data internally inside your account, you can set all of these on either at a bucket level or even at the entire account level. Now, you may find the last one of these in particular causes problems if you're trying to do sort of cross-account access, so you may selectively leave that one off. Now, access points are trying to solve a different problem. I mentioned that you can have a single bucket policy on your bucket, but within that you can have lots of statements. Well, there's a limit on how large those can get. And if you're trying to do complex access for different types of users of this bucket, then it can get very complicated. There's a risk that you overexpose data or cause problems there. So access points effectively give you a view of the bucket, a different endpoint, which has its own policy that's individual to that endpoint, and then you grant access to the endpoint rather than directly to the bucket. So in this graphic from AWS, they show different organizations all accessing the same bucket, but being granted different permissions. So that can be a useful way to segregate access. And there's also some utilities in there to make setting up things like VPC connectivity only to an access point easier to do. Some other things to consider that I don't have time to really go into any details, but you should be looking at server-side encryption for the objects you have in S3. Object versioning, which will keep track of multiple versions of your object, including when you delete them, that still remains there in the background. Multi-factor delete, an object lock are ways of preventing objects from being deleted, either without a secondary form of authentication or perhaps indefinitely based on perhaps a legal requirement that objects are retained. S3 inventory can help you keep track of exactly what's in your buckets, and perhaps if you've got some crazy ACLs out there. And Macy uses machine learning to classify the types of data you have in here, which again might be a way of detecting PII where it's not supposed to be. And that, I think, is it. If you have any questions, please hit me up in Slack. I don't claim to be an expert beyond what's in this presentation, but I can certainly point you in the right direction.